Welcome, everybody in the lecture hall. Welcome, everybody on Zoom. Welcome, everybody from the future. So today, we will continue our exploration of document stores. I actually started a little bit last week telling you about them. In particular, we ended the lecture of Spark on cliffhanger. It's that in the case that your data is nested and or heterogeneous, then that hits the limits of Spark SQL. It still kind of works, but it's not ideal. And so now we are exploring some other paradigm. I see a raised hand over there. Can I increase the volume of the microphone? Let me see. Is it better like this? Can you hear me better? Kind of. You're not completely convinced? Kind of. Even more? Like this? Yeah, better? Okay. All right. So we are exploring another paradigm. So I explained the whole impedance mismatch, right? So it's a common thing in the field of databases that there is a new idea or new shapes, and then you have to implement a database system that specializes in these shapes. And so what I explained is that people try, before they invent something completely new, they try to store it on some existing system, like a relational database and so on. But of course, that existing system would be a physical layer, right? You would have to hide it and still expose the desired data shape to the user. So what I hope you now understand is that you try to, if you try to use a relational database management system to store your documents, it's very much like trying to put a square peg into a round hole, right? Because trees just do not fit in tables, right? So this is the idea. And so this is the justification for yet another paradigm, which was the document stores, right? And so I will tell you about this. There's actually plenty of products out there. MongoDB will be our focus, but there are so many out there, but they all work in the same way. So that's the good news. Once you have learned how one works, then you will be capable of learning very easily how the others work. So the idea is that in a document store, you can have collections that have enormous numbers of documents. You can have millions of documents, billions of documents, perhaps even trillions of documents. Just to give you an impression, millions of documents, that's actually not very impressive in big data. Millions of documents that actually fits on a machine. Billions of documents, you can actually still fit 1 billion documents on a machine in some cases, but billions of them, this is where you start needing some multiple machines. And then trillions, then here you really need to go to large clusters. But most of the cases in document stores is millions or billions of documents. Okay? And the size of the data we're talking about is gigabytes, terabytes, petabytes in size. Now, we have two kinds of document stores on the market. There are XML document stores and there are JSON document stores. But that shouldn't surprise you because I told you JSON and XML, it's the same things. It's just trees. So it's quite natural that you have the two kinds of document stores. MongoDB is a JSON document store. ExistDB or MarkLogic are XML document stores. They work in exactly the same way, right? So everything in a document store is a collection of trees that look like this. So here it's a collection of 3 trees, right? That in that case happen to be JSON trees. In fact, if you remember the JSON lines files where you have one JSON object per document, this is quite a good input for a document store, right? You can take a JSON lines file and that gives you a collection of JSON objects, okay? Collections of trees. Now, there is something that sounds trivial to say, but it is something absolutely fundamental to understand. Even though we have a lot of documents, millions, billions, trillions, the size of the documents is actually not that big. So typically, many document stores restrict to 10 megabytes, a bit more than 10 megabytes. MongoDB, I think it's 16 megabytes. That order of magnitude shouldn't actually surprise you because that's the same order of magnitude I told you for HBase. Who remembers I told you for HBase, up to 10 megabytes roughly for a cell, that's the same order of magnitude, right? So we are looking at billions of JSON documents, but they shouldn't go too much over 10 megabytes, and there's a hard limit in some of them at that level. So if you try to store, I don't know, a collection of 1,000 documents of a gigabyte each, that doesn't work. You shouldn't be doing that. What would you use if you have 1,000 objects of 1 gigabyte each? Where would you put that? S3, yes, exactly. Then you would go for S3. Absolutely. All right, so this is what we have here. So a huge number of small to medium documents, a few megabytes. Okay, in practice, of course, it's very often you don't even reach megabytes. Typically, it's I don't know, a few tens or hundreds of kilobytes very often. All right, and so now I emphasize something that I kept telling you. This is all about flat versus nested and about heterogeneous versus homogeneous. And again, what you really need to remember here is that the flat homogeneous case, which means relational tables, is a special case. So if you take a relational table, it's very straightforward to convert it to a collection of homogeneous flat JSON objects. Who sees that? Right, I told you several times already. Very good. Now, what are some of the differences with a relational database management system? Well, the first thing is that we have projections, we have selections, we have aggregations, right? But we don't have joins, or at least not natively in most systems. The reason is that aggregations, selection, projections, we can do them quite efficiently. We saw in Spark that you can use RDDs and transformations to do projections and selections. We even did that in MapReduce, so it's quite a natural thing to do. But joins are very costly. I even warned you that when you want to join RDDs and so on, you really have to be careful about the size of the RDDs. And you also have to be careful about the join predicate. If it's not an equality predicate, then you might crash the cluster. So it's kind of the reason why some document stores, in particular MongoDB, do not support joins, because it would be a performance penalty. But what happens in practice? People re-implement the joins in C++ or Java based on the MongoDB API, right? So what you did is you just pushed the burden of implementing the joins to the users in the host language. All right. Something else that is a bit different between MongoDB and PostgreSQL, or generally document stores and relational database management systems, is that in a relational database management system, you have to validate the data. In fact, you cannot even put data into any table if you haven't first specified a table in a schema, right? That's the create table statement in SQL. In the document store, it's actually different. You can actually go ahead and put objects in a collection, and you don't need a schema for that. It can even be a huge mess. You can put 1,000 or 1,000,000 totally unrelated JSON objects in a document store collection. That's totally fine. It's going to work, right? But optionally, you can bring a schema. You can bring a schema at the beginning if you want. So you create the collection and you specify the schema that you want to have. And then the document store will check whenever you insert something, it will check that it's valid, right? Otherwise, it throws an error. Or you can worry about the schema later, meaning that you first drop your objects without validating them. And at a later point in time, you add a schema saying, from now on, I'd like to work with that schema. You can retroactively try to validate the previous documents. It will validate any new documents that you insert and complain if they are not valid. Whenever you perform an update, it will also check whether the updated document is still valid, and so on and so on. But it has a bit of this flexibility, something you don't have, for example, in relational database management systems, is that you can make it in such a way that if you attempt to validate a collection, but some of the documents are invalid, and you have to deal with it, it's just that they are considered invalid, you can have some sort of lax mode in which if you try to update an invalid document, it's not going to complain even if it's still invalid after that. So you can use it a bit in a relaxed fashion compared to the relational world. For whom does that make sense? Right? So we have schemas, but you're not forced to use schemas, and you can use schemas with a little bit more flexibility. This here, what you see is the names of some of the document stores available out there. MongoDB is the one that we are going to consider, but there's also Elasticsearch, very useful, especially for indexing data, especially based on text. CouchDB, that's also JSON. ExistDB, that's an XML. So whenever there's an X in the name, you can be sure it's an XML document store. So ExistDB, Cloudant is JSON. MongoDB is JSON. MarkLogic doesn't have an X, but it's XML, but they still added JSON as well later. Microsoft Azure also has, I think it's a Cosmos DB, so they have all kinds of there's also DocDB, I think, that is a document store. BaseX, there's an X, so it's an XML document store, and so on and so on and so on. Many, many, many of them, right? But the most famous one is MongoDB. I still remember when they announced that the startup reached $1 billion of market capitalization a while ago, and then they became very popular. So MongoDB it is. I'm going to introduce you to MongoDB, but again, keep in mind that this is actually general. A lot of the things are actually also working similarly for other systems, and you just need to look at the documentation. Okay, who is ready to query MongoDB? All right, so let's go ahead. The first thing that I want to make you aware of is that we are not looking at HDFS with Spark, MapReduce, or anything like that, or even S3, because we are re-entering the light side of the force here with the good old databases, just like PostgreSQL, where you insert your data and you ETL your data. In other words, we are not looking at data lakes anymore, unlike in the previous few weeks. So it's not Spark, it's not MapReduce, it's not Hadoop, it's nothing like that, it's not Pandas. This is a good old database management system where you cannot just drop files, you have to insert, ETL the data into the system. Okay? So you really have to compare it with PostgreSQL in spirit. It's just like PostgreSQL, except that it stores documents instead of tables. Now, one of the corollaries of having this good old database that is not a data lake is that once you have inserted a document into a MongoDB collection, it is not going to store it as a JSON file, right? Instead, it's going to store it in some optimized format, a binary format, right? Just like PostgreSQL does for relational tables. It doesn't obviously store them as CSV, it stores them in some optimized format for tables. And in the case of MongoDB, that optimized format is called BSON, binary JSON. Right. So I think you can see the spec online. It's bson-spec.org or something. You don't have to worry too much about the details, but what you need to understand is basically that it takes the JSON model. So this is really the JSON model as a tree. We have an object, we have a key foo and null, right? Even though I show you here the serialized text, but you really need to see the object. And what happens is that on the disk, it's going to use some special codes to basically say, this is an object, this is the length, this is the key, this is the encoding of null, this is the end, and so on and so on. So it's really an optimized binary format. It's going to take a little bit less space than if you actually stored it as a JSON, as a full JSON in a text format, right? It also comes with a bit of improved features compared to JSON, because in JSON, you only have strings, numbers, booleans, and nulls, right? But in BSON, it supports additional types. It's also capable of storing dates and a few more types than in conventional JSON, right? Okay, so this is BSON. But the good news is that if you use MongoDB, you actually don't care about that, because this is just happening behind the scenes, all hidden. When you interact with MongoDB, you actually interact with the JSON data model, right? So this you don't even see. You would really have to go to the drive and look for the physical location of the storage to actually see that. Okay, and we'll see that some of the benefits of having to insert explicitly documents and then stored like that is that we'll get much faster lookup times thanks to indices. That's something we do not have with data lakes, right? But I'll come back to that. So now that we have that, what can we do when we interact with the document store? It's a lower level than relational database management systems. So we don't have in MongoDB a query language like SQL or JSONic, as we will see. MongoDB uses APIs. So you have a JavaScript API, a Python API. So you have an API in many languages that all look the same. And this API allows you to create documents. So read documents, update documents, delete documents. These 4 words, create, read, update, delete, it's actually very commonly referred to as CRUD, so CRUD, right? So this is the paradigm that is the basics of a system. In fact, we have seen that before, because if you look at these get, put, delete primitives that we saw before, this shouldn't surprise you too much, right? Okay, so this is CRUD. And now here's the query. So if you want to query a collection and see the contents of the collection, you have to specify names like this after DB. So db.scientist. Scientist is the name of my collection. And then there is a find function. The find function is at the heart of all my reading queries. And then you can either supply an empty object or no parameter at all. It's equivalent. We see that then we can put stuff in that object. And that gives you the contents of the collection, right? Now, a few words about this. First, I insist this is not a query language. This is an API. What you see here is just JavaScript. This is JavaScript, and we have an API in JavaScript that allows you to interact with MongoDB. Second, because JavaScript is an imperative language, when you actually do find, that doesn't actually return the collection itself, because that wouldn't be supported by an object-oriented language. Instead, what you get is called a cursor, and then you can iterate over the documents with your imperative language, go through them one by one and so on. So that's called the cursor. If you are on the shell, you will automatically see, by default, you will see the documents nicely shown. But if that's too many of them, it's only going to show the first few documents and then stop. Okay, so that's called the cursor. Yes.
On Zoom for BSON. So even if a collection is validated against a schema, it will still be stored in BSON. Seems like you could save some space with a Parquet-like format, because you, for example, don't need to repeat column names.
That is a very interesting question. So if you don't validate, you use BSON. BSON doesn't require validation, right? Now, I like this question because it means you listen. When I explain you can use Parquet and data frames when you actually have valid JSON. So it could be, and we could actually look at if we find anything, it could be that if you validate the data, MongoDB figured out better ways than BSON to store it. That I could totally imagine. So we should investigate this and find out if they have some alternate representation on disk if you validate the data, right? You do have to consider, however, that you might be in a situation that you added a schema to a collection later, and that not all of the objects of the collection are valid against the schema, right? So when you add the schema, it's going to check future inserts, right? But it doesn't retroactively force all documents to be valid. So you might have a collection, let's say, with 1,000 documents, and maybe 10 of them are not valid. In that case, you still need BSON, right? Because you still have a few objects that wouldn't be valid against the schema. So if they would use a data frame-like storage format when it's valid, that would only apply if you know that the entire collection is valid with a strict semantics, right? But that's an excellent question and some homework for us to see if MongoDB started also introducing alternate storage formats. I could totally imagine that that's what an engineer would basically think like. Okay, I like this question. Any other questions? All right, let's continue with this. Yes, what did I put in here? I put some SQL. This is for a comparison. I just want to give you an intuition of the equivalent SQL query. Of course, that's only going to work for the cases that are close to SQL. So when the data is a bit close to a table, but that's not always possible. And I will explain to you how it's actually more flexible than SQL, right? Yes?
If we later add a schema, does it retroactively check the whole collection for validity?
I think, so I think at a minima, it's going to check when you change something. When you insert a new document, it's going to check if that document is valid. If you update a document, it's going to check if it's valid or not. And this is where we can tweak that if it was not valid before, then it doesn't force it to be valid afterwards. Or if it's strict, then it also forces to be valid. So this is more something future-oriented, right, when you add a schema. Now, what I would imagine if I think like an engineer in terms of workflow, if I add a schema to a collection, I would try to figure out how much of the data was not valid in the collection and fix it. I would try to have some updating and editing query to try to make it valid. But that you have to do yourself as a user, because MongoDB is not going to magically fix it for you. The details of when you modify a collection to add a schema, what it exactly does, in particular, if it does a full scan of the collection, that's also something we could look at. But in any case, it's going to apply the schema to any modification and future inserts, right? All right. So this is a case here. You're welcome. So this is a case where the data is flat and homogeneous, because I really need to start somewhere. So in fact, this would also fit in a relational table, right? And then you have the equivalent query. Something I did not put in there is that in every object in MongoDB, there is an additional key that is special, that is underscore ID. And underscore ID contains something that is called an object ID. It's automatically added by MongoDB. I'm not showing them on my slides, but you should know that they are there. It's as if we had an extra column in PostgreSQL that assigned some record ID, right? So just know that it's actually there. Okay, now what if we want to select? So that's a selection. A selection in SQL is select from where, and you have this predicate here. That's how you do a selection, right? If you want to do with the JavaScript API of MongoDB a selection, you have to pass here a criteria. What is very interesting is that this is done in the form of an object, right? So here it's a JavaScript object, but you know that this is where JSON comes from, so it's something native. We have an object that says theory is relativity. And what we have here, the way that these predicate objects look like, it's very close to the original document. It's very visual, right? So you're looking for the cases where theory is relativity. That's going to give you this document and this document, but not the two in the middle. So the first and fourth documents. All right, who is with me? Very good. So this is a selection. Now, this is a projection. A projection is newly using a project function. It used to be a second parameter of find, but now they have modified it a bit. I suspect under the influence of Spark APIs and a lot of the modern APIs. So now it's separated as an additional function, so .project. And what you do here is that you specify your keys that you want to project to, so first and last, with a 1. 1 means you include it in the projection, 0 means you exclude it from the projection, right? So in that case, we include first and last, and you have first and last in here. That would be in the select clause if we were using SQL. I still kept the selection criterion that is here, but this is the idea. And so basically, if you add this project here, it's going to return these two documents, but projected onto first and last. We still with me? Very good. Something more. I told you 1 or 0 in here. Well, in SQL, we only know how to project onto something. So in the equivalent of SQL would only use ones everywhere. What does it mean when you use a 0? It means you project away. You're basically saying, I want all of the keys except this one and this one and this one. That's what it would do with a 0. Everything except. you cannot mix the ones and the zeros. Either you have just ones everywhere, and then that's the semantics of the select clause in SQL, or you can zeros everywhere, you have zeros everywhere, and then that's projecting everything except the keys you specify. Okay, yes?
This seems sort of like a clunky syntax for this. Like, couldn't, instead of like having like a generalized project thing that both like you can either like give a JSON that will emit something or like do everything except this, couldn't you have like something that does the opposite of project, and project would just take in like a list of the fields that you would want, and this other thing would take a list of the things that you want to exclude? Or
so that would be the JSONic way, right? There's a project function in JSONic that does that. So this is really a matter of API. And this is why I warned you, this is not a query language. This is an API. And because it's an API, it's kind of forced into the JavaScript model. In fact, if you look at the Python API, it's going to be different. It's not going to use the same conventions in Python. So this is my warning to you. This is really not a query language, and you really have to look at the documentation. In fact, the fact that it seems a bit arbitrary, I mean, why one, for example, could have been two, could have been a list of fields and so on. I absolutely agree with you. And this is why it's an API. And this is why, from a query language perspective, this is not the end of it. This is not the final product that you want. And in fact, some of the document stores do have query languages similar to JSONic. Right? I think of Uncle, AQL, and so on. So they are query languages, and then it's more natural to use. Right? So if you feel a bit uneasy seeing this, you are not the only one. I am too. Right? And again, warning: this is an API.
thank you.
Did I answer your question? Yeah. Okay. Right. But of course, I need to specify an API is not a bad thing. An API is an intermediate building block for building a query language, because then you can have some query language on top of that, and the query language will be implemented on top of the API, right? The end user will speak the query language, but then inside you would still use the API to compile the query language to the API. All right. So projecting away. So this is what I told you with the zero. So it removes everything. And why does it make sense in PostgreSQL and not in PostgreSQL, in MongoDB and not in PostgreSQL? Because in PostgreSQL, you know all of your columns. So if you say, I want everything but that, then just look at the schema and just put the other columns directly in the select clause. But in MongoDB, because you don't have a schema, you don't know which keys you could have. So it makes sense that you want to project away keys, and you cannot express it with what? You really have to put a zero in here because you don't know all the keys that they are in there. So this is why we have this projecting away, and that's something you don't have in SQL. What about and or, in the query? So if you want to have some conjunction of predicates, just put all of them in the same object. Like this is a conjunction of the two. It must have both last equal to Einstein and theory relativity. In SQL or a full-fledged query language, you would have some and logical connector. Or is a bit more involved. And again, I'm coming back to the question. This is basically what you commented on. Here, it is a bit unpleasant, right? But again, this is an API. And the goal, the design of the API was to try to have everything as a JSON object, right? So in order to have an OR, you use these special objects that have a $ key. And whenever you have a $ in MongoDB, it means that it's a keyword. It's special. So it means it's not the key $OR. It is handled specially in a special way by MongoDB. And what MongoDB would do is that when it sees the $OR, it's going to take what's in the array here and check for either that or that. So either you have last that is Newton or you have last that is Einstein. And then it's going to return these two documents right here. So you see here, there's some asymmetry because of the API between the and, that is a bit more pleasant, and the or, that is a bit more circumvoluted, but this is how it's done, right? And of course, in SQL, you would just put an or, and again, if you have a higher level query language like JSONic on top of this, then you would have also a more symmetry between the and and the or. Then you have other keywords than just $or. You have many, many others. You have, for comparisons, for example, you have this $GTE and there's LTE and so on. And that means the publications is greater than or equal to 100, right? So that would be what you would write in a high-level query language or in SQL. So that would select this one, excuse me, but not this one or this one. Excuse me, I'm speaking too much. That's probably why. So greater than or equal to 100. Who agrees with that? Okay. And now, if you feel uneasy seeing this, you know, but again, it means you understood how important it is to have a high-level query language on top. And again, this is really an API. What about heterogeneity? Well, is there a question? Yep.
Oh, I'm wondering about the or clause. If we could go back a couple. Oh yeah, thank you. Is it possible to like do this with different fields here? Like we could do last Newton or first Albert. Oh, okay.
Yes. Yes.
And then can we also like factor out like the last thing here, where like we could do like last colon or $sign or and then Newton Einstein, or would that be unkosher?
You can factor it, but I think there's a few constraints on the way you can factor it. And it's the kind of factoring that gives you headaches when you start to try to figure it out. Yeah, but again, that this is making the point that a high-level query language is better, right?
Thank you.
The only people who should ever do that should be the data engineers who implement the query language. All right? Yeah.
So when we're doing comparison, since we don't have a schema, does it mean that it's going to be automatically lexicographic order instead of regular like integer float?
So this is a very good question. And the way that this is handled in MongoDB is that any two values can always be compared. Always. You can compare an object with a number, you can compare an array with a string, you can compare a number with a Boolean and so on. The way that MongoDB handles the order is that it first orders by type and then orders by value, right? So I don't have the exact order of the types in my mind, but you have to consider that you first have all the Booleans, then all the numbers, then all the strings, then all the arrays, then all the objects, and so on. So there is like this an order, and so it will never give you an error. It will always be able to tell you it's larger or smaller. So this is how they solve it. Right.
Thank you.
Yeah. So this is again an example of heterogeneity because it's not going to throw an error. It's just going to still work if the type is different. But you have to be careful because again, if you have strings, then the strings are not going to compare. It's not going to cast them to numbers. So the strings will always be either greater or smaller, but it's not going to compare anything with the content of the string. All right. Yep.
Sorry, just one last question. So for like ands, is it possible to do like sort of a dependent thing where like, let's say like the field of like if we have numbers, the field of one thing is some number, and then the field of some other member of the JSON is like n+1 or something. Is it possible to express something like that in this?
You mean to nest and then or within fields?
Like if we have like I don't know, like sorry, like one field is like the number of people or something, and then like something else is like I don't know, the number of people plus something else.
Ah, so you would like your predicate to check that one is the other plus one.
Yeah, like a dependent product or something like that.
So I don't know if find would be powerful enough to do that, but I think that you would still have a way to do a full scan with your predicate written in JavaScript, and then you just iterate manually over it. It could be that there's also in the API a way to supply a JavaScript function that just does this check, right? But that would already be advanced to do something like this. Right?
Thank you.
There was another question over there.
You said that the types have some kind of defined order. So for example, let's say Booleans are always greater than ints, and then I search for a field with greater or equal to 100. Does that mean that all fields that then would contain Booleans are also returned? Because that is kind of not the behavior that I would expect.
It depends on the order of the types. I just don't have it, but by heart. But if it is the case that all Booleans are smaller than integers, and your query is greater than or equal to 100, then the Booleans will never be returned, ever.
But just hypothetically, if it were the other way around,
then all of them. If it was smaller than 100, then all of them would be returned.
is there some way to say just compare with numerical values and ignore all the rest?
You probably could use an AND predicate that I think, if my recollection is correct, you have some minimum int and maximum int, and you can, or maximum number, minimum number, and then you can use these as bounds in order to control that you want things to be numbers.
Thank you.
Yeah, you're welcome. All right, so on this slide, you see that even if the data is heterogeneous, that query still works. So, right, you can have additional fields, missing fields, and so on. And in that case, if theory doesn't even exist, then it's just not including the document, right? It's checking that theory exists and that it has the value you want. For this purpose, null is considered by MongoDB to be the same as absent. So if you say theory null, then it's going to return both when it's null and when it's absent, right? It's the convention taken by MongoDB. That's like you have here. If you say theory null, that's returning the last object. Then something to be careful about, and again, I warned you, it's an API, so you're going to get headaches, is that not just the dollar, but also the point is special. So if you say name point first in here, it's not going to look for a key that looks like this, but it's going to look for a key first that is nested in an object under the key name. So in fact, this is the sort of thing it's going to return. So name.first, it's really a navigation, the dots, right? So this is something to be aware of. What does not work, because some people are tempted to write something like this when they want to look up first equals to Albert inside name. But when you do that, that's an exact match. It's going to exactly find this object. So this is not going to be returned because that's not exact. This one is returned. That's the exact same object. And here it's not returned. Okay? So that's a bit of a warning. You really need to use a point if what you want is to filter based on a nested field. Then something else that the way it behaves, if you have here a specific value for a specific field, it's also going to include documents where that value here is in an array of that name, right? So you really have to read the documentation. There's a lot of small things like this that it makes it basically very flexible to use. But you have to go through a lot of totally arbitrary design decisions, right? You just have to be prepared for that. The only way you can know that is to read the documentation to be aware of this behavior. But this is how it deals with nestedness inside arrays. There is also an operator called $in that checks whether a value is inside a specific set of values. It also exists in SQL, by the way. You also have the in keyword in SQL. So here it's in ETH Zurich or EPFL. Note that it would be equivalent to a $or with University ETH Zurich, University EPFL, right? So or $in, you can use one or the other. So here it's going to return this one and not this one. And in is the opposite. That's yet another one, and there's tons and tons and tons of other keywords. All right, so this is the overview for the find and the project methods. Then we have others. We have count, for example. So count is going to tell you how many results are returned in here. In fact, at that point, since we've studied Spark 2 weeks ago, that shouldn't really surprise you, right? You chain these methods a little bit like you chain the Spark transformations, right? When you work on the RDDs or data frames. So this dot count would look the same in Spark. You also have a dot sort, again similar to the Spark transformations that would sort the RDDs, except that here you sort documents. And now again an arbitrary convention. 1 means ascending, -1 means descending, right? Something else that you need to be careful about is that when you specify the sorting criteria, the order is important. And this is something I feel very uneasy with because normally in a JSON object, the order is not important, but in fact, MongoDB is order sensitive in the way that it processes the object that you put in here, right? So it's a breach of data independence because normally in the model, you're not supposed to see any order, but in fact, it does specify the order of the sorting criteria. This is equivalent to in SQL, order by, founded, desk, and so on and so on. Who is with me? All right. Who also feels uneasy that suddenly the order of the key matters in sort? You don't feel uneasy about that? I feel very uneasy about that. Normally, objects don't have any order. Okay. But I saw some raised hands, so some people agree with me. Then there is skip and limit. This is like the limit and the offset of a SQL. So again, there's nothing new in here. So here we skip the first 30. It's like offset 30 and then limit 10. All right, so you can chain them. The order doesn't have any meaning. You can also put the skip in front of the sort or the limit in front of the sort. So it's not like the Spark transformation where the order is important. It's not like this. Here, you're just specifying your instructions to MongoDB, but it doesn't matter in which order you're actually giving your instructions to MongoDB. So this is also one of the small things that can be confusing about the API. Then you can use distinct in order to find all the distinct values of some field. What else do we have? We have the super powerful aggregate function. And I'm not even going to explain that because in fact, if you look at this, you will recognize basically a Spark series of transformations, right? It's like you have the creation, that is the collection, the transformation, filter, group, sort, and so on, and the action, the stages. So in fact, what you have here in this function is a mini Spark. It's a mini map reduce or a mini Spark, and you can define these aggregation pipelines where you can have a chain of transformations. All right? So I'm not going into that because since you know Spark, if you would take a look at the MongoDB documentation, it would be a walk in the park for you to learn. It's all the same concepts that you've seen before. Then we have insertion, deletion, and so on. So here you have insert one, insert many, delete one, delete many, and update one, update many, depending on the number on which you have an effect. In that case, you insert one document, so that adds the document to the collection. This is where validation kicks in. If you define the schema for the collection, this is where it's going to check if that document is actually valid against the schema. Then we have update many is another example. There's update one, update many. Update many here is going to basically look for all the documents that match this predicate, what you would get if you use find with that predicate. And for all of these documents, it's setting century to 20, right? So it's modifying the value. And because it's update many, it's going to do it for all the documents. If you say update one, then it's going to only do it for the first document it finds and not for the others. Again, that I don't like. There's no quotes around here. And again, it's kind of lenient. It's not going to force you to have quotes everywhere in here. All right, update many. Then we have delete many. Again, they all exist. Delete one, delete many, update one, they all exist. Delete many is going to delete all the documents that match century equals to the string 15. Okay. Now, this here, again, is very complex. And you will see this is why we have query languages. On top of that, the query languages are here precisely so we don't have to deal with these things, and only the implementers of the query languages should ever have to deal with these things. All right. Now, I would like to say something about what happens, if it doesn't ring, when you modify a collection. If you try to update something, if you try to, there you go, the ring. So I'm going to tell that to you right after the break in 15 past 3.